Welcome everyone. Welcome to Data Pulse. This is the first episode in the session of live webinars where we will be talking about unifying the operational and analytical planes. And here we will be mostly outlining the problem space and talking pretty high level about the concept that we want to discuss deeper in future episodes. My name is Jan Siekierski. My primary background is event-driven applications and the operational plane in general. I've been working in software building stuff like this for roughly 10 years, 5 of which event-driven microservices as a tech lead. And I've seen quite a lot, but also my interest in Kafka and in data streaming in general, because this is a wide landscape, has been growing. And right now my activity concentrates about this problem in many different forms, including this. And together with me is Sachin.
Hi folks. I'm Sachin. So I have complementary work jobs as compared to Yen. So I have been mostly working on the analytical side, data engineering and data analytics side, mostly around all the data warehouses. You name it, Databricks and all those things, and then like the open standards such as Iceberg, Delta Lake, and things. So currently I'm working with Arnin as a senior data engineer. I'm leading their data platform initiatives.
And in these webinars, we were talking with Sachin a lot about how we see things, and they align a lot. What we want to be talking about is how can you build certain capabilities bottom up without migrating to a comprehensive enterprise platform. Because there are a few reasons. One is that these large platform vendors, they already have a lot of content around that, and they are great solutions, but they come with certain problems. One of this is vendor lock-in connected to vendor risk. And it doesn't necessarily mean that your vendor will go bankrupt, right? This will be problematic, but with large players, this is not an issue. But one situation that can be a missed opportunity is if you have a vendor lock-in and then something happens, like happened on Azure, when 1 year ago Azure changed their pricing model very deeply. They removed all of the cross-AZ networking costs and became the best platform to operate Apache Kafka by far, like a few times cheaper. So if you have a vendor lock-in, you are less elastic to adapt to market opportunities. And on top of this, these big comprehensive platforms, they are providing a lot of capabilities. This can be pretty complex. Very often you will not be using all of them. And because they are so comprehensive and large, they are usually the most expensive as well. And many organizations will not need them and will want to add some smaller solutions, have some high priority solutions to their problems in the beginning. And we want to focus on this, on an incremental approach where we add certain capabilities to our enterprise architecture. We have control over it, and because we add them ourselves, we have much more ownership. And this is something that will be the main theme of this seminar. And also, it's a very interesting or maybe a nice way to think about these things, like not thinking about one product, but think about capabilities independently.
Yep. So like from the slides that you can see, this is a data pipeline on Databricks. So with this, what we wanted to talk about is how Databricks thinks about streaming. So streaming is a pretty small area where they focus right now. They are mostly focused on the Delta Lake and Lake House sort of scenarios, but then it varies product from product. So with this, if you can see, it's a medallion architecture. So what medallion architecture is, it's comprised of 3 layers: bronze, silver, and gold. So bronze is always the rawest form of the data, and then it gets a little modified in silver layer and then aggregated to form the gold layer. So here they are using 2 sources. One is like this. This is just one example. There are other alternative and use cases. So you can set up autoloader, which will read directly from the data that you are posting into a blob or object storage using the cloud storage. And then you can also connect your Kafkas and streaming queues, like different implementation of those. And then you can create a streaming table. And then finally, you can create a materialized views over them. And the materialized views will have a lot of much more efficient than your normal tables and things like that. And we'll go more in detail when we'll discuss more on the lakehouse patterns on these on this specific pattern, but then at a high level, this is what Databricks thinks about the streaming as an area.
And on the other side is the perspective of Confluent, which is an enterprise platform that's coming from the data streaming world. And they see things very differently, right? For them, the integration between operations and analytics is like the central point of the enterprise. And both perspectives are valid. They just see things from a different angle. This is the part that we want to be talking about. But before we start, we want to talk about why there is a divide in the first place.
Yeah. So to understand why there is a divide exist between an operational plane and analytical plane, let's walk that through with an example. So let's talk about an example. Let's take a ride-hailing platform such as Uber, right? And there you are booking trips. Now, when you are booking trips, what would happen is your payment format will get logged, the trip will get in progress, and your search pricing will get updated depending upon the supply and demand on that particular area. Hey, hi, LinkedIn user. I don't see the name, but yeah. So we just started. We are just on the slide number 3, but yeah. That's on the that's on the operational part. So what happens is these are the operations that happen whenever you're trying to book a ride. So now let's say you have 500,000 users or even more requesting for a ride in Bangalore at the rainy weather that we have right now here, right? So that all those like this a bulk ride that's going to the database, and it will get rows level logs to get those. And then let's say, unfortunately, your data science team also wants to do the analysis of such pricing depending upon supply and demand on that on the particular city, Bangalore, right now, right? So when they do that, what they see is they have a like whole select star from table, because the table where the trips information is loaded, where the right requested are also polling that table, and your search pricing table updation logic also polls that, but it polls in a different way. It do select star whole table. What it will do is it will invalidate the cache, and also it will take the table level log rather than a row level log, right? So what eventually it will result, your Uber app will show finding the driver for infinite times, and let's say someone from ops goes and kill that particular query. What will happen is your search pricing table is also not updated, so you are not achieving any of the objectives. And this has happened in the past. So Amazon in around 2012 or 2013, they had this quarterly reporting logic which accidentally hit the production databases, making the Amazon go like halt for in nearly 40 minutes, resulting in around $4.8 million revenue loss approximated.
Yeah, and this separation happened a while ago. In the past, we had data warehouses or even just mirrored operational databases. Then we had data lakes. Now data lakehouse is in place, and this separation results from different requirements on both systems. In operations, what you need is low latency, because transactions are happening in real time, and very often there is a user on the line waiting for the HTTP request to come back to you. Even in event-driven applications, you care about latency a lot. You have high concurrency, because not always, of course, but very often you will have thousands or sometimes millions of users at the same time using your systems. The operations are very small, because you don't need to access the whole world at the same time. You just need one user's data very often. For example, adding items to cart, you just need your cart, and that's it. Also, something specific to the enterprise environment is that you have a high variety of applications built in different technologies in different times. Some of the applications running have been started 30 years ago. So we have different technologies, different languages, different architectures, and often also different governance and compliance requirements, because financial data and private information is very sensitive. On the other hand, if you are managing a fleet of scooters, you don't need to protect the position that much, and there are even less sensitive types of data. So there is very high diversity in the operational plane, and also because many applications are not working with very high volume. Very often, in the scope of the whole enterprise, development costs dominate. Some applications will have high volume, and some companies, some products will have very high volume, and then you need to accommodate this. But development costs are very high in this plane, and very often you have low traffic products that have 5 or 10 people working on them. And this just creates a very different cost profile, very different priorities on the architects designing tools for these worlds.
Yep. Talking about the difference that we have at analytical layer, so the latency is little less relevant. So it's not like life and death as in the operations. At the operations, you are adding item to a cart and you are sitting online to check the status of the cart. But at analytics slide, you are still okay if you recommend something to purchase on Friday night, maybe an hour later after you've made a purchase. There's not a like life and death situation in latency at an analytics side. Concurrency is definitely low as compared to operations because concurrency is like the queries are heavier and the queries are fewer. But then there are like some exceptions where you have user facing dashboards. So that user facing dashboards will have a lot of concurrency, but then like these are still not that high in number. Mostly the use case that you or we would have been dealing with is around the low concurrency system. Transaction on long data set as compared to the operational system, the transactional, either you consider read or you consider write. So the write happens in batches. The read happens also like it will query, let's say, last 3 years of data to give you the to give you the recommendation on what you would buy on Friday evening around 5 p.m. Storage is columnar, partitioned, and denormalized. Because we are querying a huge data set, that's why storage is columnar and it's also partitioned, denormalized to optimize the efficiencies. If to make the queries more efficient, and then operational and then storage are also like as compared to operations. Operational storage especially dominates the cost. So like in operations development which dominate the cost, but here operational and storage dominates the cost, and that's why we have like different patterns of compute. So you will have your duck DBs where you bring your DB engine into a Python process and run like some dev work or CI test. Then you have like lakehouse warehouse where you would store data in your system, either object storage in terms of lakehouse. In a warehouse you'll store in there, and you support, let's say, SQL workloads or dashboards. And then you have like ClickHouse specific use cases where you have real-time OLAP systems and with a high concurrencies. So all these patterns exist. You choose and you pick and choose what you need. So you choose a specific pattern and like solve your need, and depending on that, the cost will play a factor in it.
And because of these very different use profiles, what is present is the foundational data structures are different. In operations, the foundational data structure is like row-oriented storage. So either sequence or operational databases have append-only logs in the lowest layer, write-ahead logs. Whereas for analytical purposes, column-oriented formats, Parquet, the most popular one, they support row skipping, column skipping, because very often running analytical queries, you are interested in filtered results, right? So, and also columnar formats are more space efficient, which is especially prominent when you are talking about wide data set, which is very present in analytics. I saw a benchmark once about a data set of 184 columns, and in this wide data set, the difference was 3.6x versus Avro compression or compressed Avro format. And because storage costs are the primary driver cost here, this is 3.6 times cheaper cost of running your platform. This is it's just the default way to store data. Another problem, another challenge in integrating this is the legacy systems and the tooling chaos. If you have 50 different development teams in the operational plane, they are using 7 different languages, 4 different databases, and you want to integrate all of this and older and newer messaging buses. This results in a lot of chaos and a lot of overhead and a lot of complexity in navigating the competence, the skill management of the whole plane, of the whole department. And also it makes governance much harder, because if you want to govern this, sometimes tens of different technologies, it's just a huge overhead, and very often results in security issues where people just assign and cannot monitor all of this at once.
Yep.
Yeah, and
Yeah, so just to add like maybe an analogy to that, like maybe you have two different different traffic lights have different rules. So at some places at red you will have to go, and at some place at red you have to stop, right? So fragmented governance is like cause that for you. So it's better to have that unified, and then like again the multiple copies of data like it will be equal to multiple points of failure. So there was a incident that happened recently with Air Canada, where the chatbot was using was reading from the database which was not updated, whereas their production database was updated. So the folk requested for a cancellation ticket or something like that, and when he was going through a very tough time, someone's demise in his home, and he was booking cancellation or something like that, and the chatbot gave wrong information or not so updated information, and that resulted in a lawsuit to Air Canada. And then like there is a last point on which me and Ian have already been discussing, is on like operations often don't feel the pain of the bad data that they pass through to us, and at the analytics layer then we have to put all the compute just to clean that up, or have like 20 lines or 25 lines of code just to protect us so that the downstream pipeline don't break.
Yeah, and some of the solutions and the ones that we want to be talking about a lot is using open data formats for both sides of the integration. And this is already done in many organizations, not all. The standards for good standards for integrating this is you have the Kafka in the operation plane, which supports very high volume, is extremely scalable, and at scale it's very cost efficient. And it has a super wide ecosystem that I think 19 or 20 languages have Kafka producers and consumers. So you can just publish your data to Kafka and then handle how it is consumed from there, both consumed in the operational plane in event-driven architectures and in analytics when you stream the data from Kafka to a destination store. And this store, right now, the most popular format to do it is Iceberg. Iceberg is an open table format, and both of these formats have many different implementations, many different clients. And this is the beauty of it, that you have a specification and you can plug in, you can replace the way you implement this with another solution if you find a better one. And also we can plug in many different clients to that, so that you can have client that's using the optimized for the right purpose. And Iceberg is great at this. And what has emerged, I think most of these solutions have emerged in the last half year or last year, is the table topic duality, which the way it works, you have an example of this is TableFlow in Confluent. You have a Kafka schema, Kafka topic, and an Iceberg schema, and there's a single schema that's used by both of the solutions. And the way it works is data gets streamed from Kafka to Iceberg. You have a single data structure, so you can both have the right efficiency of Kafka, so single digit latency if you set it up, and the access and the analytical query support of the Iceberg table. And very recently, I think 2 or 3 weeks ago, Confluent also announced the new feature snapshot queries, which was present in Flus, another solution that's built around this architecture. And snapshot queries allow you to run a query through Apache Flink, run a query that will be executed on the Kafka stream and the Iceberg table in parallel, so that you can both have the query efficiency of querying an Iceberg table and super fresh data, because you execute your query on Kafka, and only a tiny fragment of it it's actually is processing the stream. And the open standards make your life much easier. And historically, very often enterprise middleware solutions were used for data integration, where they would have integrations with many different databases, many different messaging systems and destinations. But right now, you actually can just use Kafka for this purpose and get all of these benefits. You have the tooling flexibility. There are many different implementations of Kafka. And it's much easier to get people to work with it, because of the popularity of the formats. You don't need to find some niche developer that actually understands how this program has been built 10 years ago.
Yep. So gone are the days when you have to move the data to different tools. So as to make your Flink work, and then you have to make your Spark work and things like that. You just put the data into Iceberg format now, and then you can put any tools, DuckDB or uh, Flink or Spark or whatever is the use case to consume from it and do the operation. So the ETL, the unnecessary ETL is not no more required now. Uh, the Iceberg is currently the main focus in this area for at the analytical layer, but then everything has its own weakness. So the Iceberg, the major weakness is this metadata bloating. So whenever you with a streaming use case where you will be passing a lot of data, like lot of file changes will be happening. It will be creating data files for each manifest list, manifest file, metadata and snapshots. All those metadata tree that we have for Iceberg, it will create that, and that's like a overkill for this particular situation. Also, the concurrency is not that great. So we'll be discussing about Apache Payman just now after this point. But the concurrency is not that great because the way to conflicting writer gets the privilege, gets the date, occupies that particular thing is by having the atomic swaps, and whosoever wins will have the other one to wait and then retry. So it works like, let's say, for few concurrent reads, but like if you have like 1,000+ concurrent reads or writes on things like that, Iceberg may not be the good solution. But then like different alternatives are rising, like Apache Payman and things.
Yeah, and Iceberg, Kafka, and snapshot queries. This is a great starting point. New solutions are emerging to tailor specific use cases. Pymon is something that I wanted to mention because it has an interesting structure, because it has Iceberg's capabilities of supporting analytical queries and has this columnar format and summaries and so on, but also it allows you to write to it extremely frequently, like you write to a stream. And there are other innovations happening in the space that we'll be talking about in the future episode as well. And then there is the topic of data governance. And once you have this common layer of open formats on both sides, you can build unified governance that's built on top of both sides. And these comprehensive platforms like Databricks, Snowflake, Confluent, they provide their own governance, but owning your governance gives you this elasticity and allows you to actually substitute these technologies that are under the hood.
Yeah. So let's talk about these things which are like the problem that we need to solve with unified governance, right? So schema management. So think about this as like two architects working on the same blueprint. That is what we will have if we will not have unified governance. So someone will put the walls of a room at a different place in a blueprint, and someone will put the fire cables or wire cables at that particular wall position, right? So that's what will happen if you will not have unified governance. And then there's a data quality. If you do not have a shared vision of data quality across the operational analytical layer, then that's a problem. So a very one example with the data quality was so NASA around in 1990s, NASA launched an orbiter for Mars to get the weather and all those information. So one of their application was reading force in Newton, and the other one was reading force in pounds. And that was a major reason. Because of that, the orbiter failed, because there is no coherence in the unit that they were measuring. The data lineage is also pretty important because this will give you the unified view and also help you assess the impact. So let's say if you shake a particular table, what will break downstream? If you shake a particular topic, what will break downstream, and what are the upstream relations? So you need to have a whole end-to-end data lineage. Then there's a data observability and discoverability, just like smoke test for your data, where you like check the anomalies, log the things in data catalogs, so that you don't do the duplicate work. Every table that you create is basically logged in the catalog. Every topic that you produce have its own schema registries and are logged, like this is a topic that's writing to this particular table and things like that. I think Yen also had some example on the data catalog part.
Yeah, the data catalogs, it's a new category of systems. I think half a year ago, maybe a year ago, Databricks open source unit catalog, but there are also different products in the space. Data Hub is one worth mentioning as well. Also,
Yeah.
Confluent has their own stream catalog. What it supports is documenting your data products, documenting your either your tables or your streams or actual data products. And it just helps a lot. It removes a lot of the overhead that's necessary whenever somebody wants to start consuming your data. In the past, I've been in this situation many times that either I approach someone or somebody approaches me to understand what's actually in this stream that we publish. But there are tools that actually help with. I clicked something. There are tools that actually help with documenting this. Without it, you can still document in Confluence, in Confluence, right? But this is a new product category that's emerging that's supporting all of this, what we are talking about. Cost allocation is also a challenge because you can tag your resources and then calculate costs related to running your platform, the storage, the compute, the consumption, and so on. It is still a challenge though, because certain things are hidden. For example, it's not that easy to track egress traffic from your Iceberg tables and correctly allocate costs to the one that's incurring them. So it's one of the problems that data governance that's within the reign of data governance. Access control and security is extremely important, especially more advanced features that right now I think are only present in the large vendors, like policy-based and tag-based access control, the way you can define your policy once, and then you say that every PII piece of data needs to be encrypted at rest. Or at the source, so in Motion as well, using one of our encryption keys. And then you just tag the data, right? And there are even tools that allow you to find PII data in your logs, so that you can connect some alerting based on detected issues. And this is all of this is a pretty large problem. We'll have a separate episode dedicated only to governance.
Yeah, I just have one point or analogy to add to the cost allocation part. So it's a funny one. I don't drink on Mondays, but let's say if you go to a bar, the most costliest bar that you know in your city, right? And you don't have to pay the bill. Your CFO has to pay the bill, right? And then there is like your team is not tagged that this is the team which is consuming this particular data pipeline, and CFO who is not even going to the bar at that day gets the bill that this is that this is the bill that you need to pay. So that's like at production side you can still tag it, but as Ian mentioned, but at consumption side, if it is not tagged, then you do not know which team is consuming what, right? And what's the cost, like that, basically the FinOps part that we can discuss. And we are, like as Ian mentioned, we are definitely so this is basically a teaser where we want to take the depth, and in each episode we'll go in more depth of each of the topics that we want to cover. So these topics will be coming in a future episodes. Coming to data quality, so data quality is pretty important in the analytical world, especially. Not so I'm not saying it's not important in operational, but it is significantly important in analytical world, because CXOs make decision over the data using this data in the analytical world. So analytics are downstream. So if you make any changes in your upstream and you do not propagate that into the downstream, your downstream will be broken. So make sure that you treat your upstreams as a product and have specific SLAs, right? Otherwise, you would not know that. So let's take an example. So your ML team is consuming a pipeline, and you do not have any SLAs for your specific pipelines. ML team needs it updated every hour, and your pipeline was broken, let's say for a couple of hours. You don't even know, if you don't set up SLAs, that because this was broken for a couple of hours, you need to update it again on. Setting up the product, all the upstream, either it's table or stream event or anything like that, you set up as a product and set up SLAs. Schema validation evolution is pretty important. You do it via CI, so you should put all the schemas in Git and have CI enabled for them, and let the developer do the integration test before they put any breaking changes. Then there's data quality tooling, the different tools like you can. So there are two different philosophies in data quality. One philosophy is you predict all what can happen, like the assertions, and put it beside the code. So that is what great expectation and DBT test or DLT verification, all those things too. Then you have like anomaly detection, where it will analyze all the metrics, and then it will do an anomaly detection over the data and will highlight alerts or things like that. So those are two different school of thoughts in data quality. Then data quality observability versus enforcement. Yan has a lot of interesting point on this. I'll just close this with one example. So Netflix blocks all batch pipelines which do not follow a specific threshold of null ratio in a specific column. So this is like two parts. One is observability, where you are setting an observability that for each column I need this much null ratio, and also enforcing them, that you just block all those batch pipelines which do not follow those data. I think Yan has some very interesting examples on this as well.
Yeah, because when you start enforcing data quality or enforcing schemas, if you do this all at once, you will break something inevitably. So one approach that you can do, and it's like the perspective of organizational transformation less than tooling, is that you can start monitoring data quality, present this on dashboards, discuss organizational accountability, who's actually responsible for this piece of data, and what are the timelines where we expect them to improve. And once this is signed and this is visualized to them, then you can actually discuss the timeline on when you start enforcing. So you can build the tooling first, present the results, and then only enable the validations whenever everyone's ready. And so this way you can ease the organizational change. But the wider context of the organizational change is a trend called shift left. You might have seen this name before. And the core idea here is that instead of doing this medallion architecture where we have the bronze layer where we flash all of the data in the raw form and only then the analytics clean it up, instead we focus on creating incentives for the data producers to actually produce silver layer data quality in the beginning. This is done because there is a lot of money to be saved. There is a lot of overhead, a lot of failures resulting from quick fixes and cleaning up data that could have been clean in the beginning. And right now we have the engineering solutions that support this approach pretty well. Schema validation in the Kafka brokers, it's an emerging feature. There are certain solutions that allow you to define data quality rules before they get accepted by the broker. And this process, it's on the cross-section of engineering and organizational change, organizational transformation. So toolings only enable the transformation, but the transformation is really what has an effect. We'll have a dedicated episode about this, but in the large perspective, this is the concept of the data mesh, where you decentralize the organization and each domain is independent, and analytics work closely with operations within this, and many other concepts. It's a big topic. But then there is this smaller concept of data products, where you publish your data to a Kafka topic. You say that this is our data product. First of all, this is our data quality. This is integrated with validations, so you can expect that these validations are enforced. On top of this, if we commit any faulty data, we provide SLAs on how we commit to fixing them. We make these products self-discoverable, self-documented, and self-service approach to getting access to data, so that you don't even need to ask us. You just click here, and a request to get access gets done. And this is something that can be built from the bottom up. This can be done without a large stakeholder buy-in and enterprise-wide transformation. This is something that you can start building within a domain. If you already publish data that's consumed by others, you can add certain documentation and quality aspects to your data and start doing this right away. This was the high level of the topics that we will be talking about. And this cycle, we are planning 7 episodes right now. This was the first one. But before we close, I want to say a few sentences about what's possible. Once these ideas are implemented, and there are some organizations that have implemented them already, but a lot of this is pretty fresh. What you can do is the operational state is publishing to Kafka, using Kafka as the integration layer, both with the analytical state and with other teams in the operational state. In event-driven architectures, you can just publish to Kafka and then trust that the consumers will be able to read this data efficiently, and there will be no bottlenecks because the solution is very scalable. Then on the analytical side, you'll have an open table. Both will share the same schema. Processes that are moving this data are taking care of integrity between those, compaction, and so on. And everything here is pluggable. If a new tool emerges that you like, you can just swap it. And that's you can also connect with many different technologies, the one that fits the purpose best, right? Sachin mentioned that you can have different user profiles for your Iceberg tables, and different tools are good at different things. With Kafka, it's similar. You might have 10 different languages in your enterprise, but all of them are speaking Kafka language, so they can just publish data to Kafka, and everything just works. And then you have these data products where data is actually taken care of, and you publish good quality data where you have communicated what the structure is, and this is actually enforced.
I have seen like C# and Python and Java. All those things are like acting as a producer and consumer for Kafka. In some cases, Rust as well.
Yeah. So this was all that we have prepared for you today. Thank you very much for being here. The recording from this will be uploaded to our YouTube channel. If you have any questions or, most importantly, suggestions on the topics that you would like to learn more about, you can reach out to us on LinkedIn.